following organic video short entails using the pKa table to practice drawing Lewis structures. On the pKa table, you will notice that none of the heteroatoms have lone electrons. Therefore, we can take one of these acids or bases and draw out the correct Lewis structure with all electrons. Let's take, for example, nitric acid, HNO3. There's one hydrogen, one nitrogen, and 3 oxygens. So we take molecular formula, HNO3. Hydrogen has 1 valence electron. Nitrogen has 5 valence electrons. Oxygen has 6 valence electrons. There's only 1 hydrogen atom, therefore there's 1 electron from the hydrogen. There's 1 nitrogen atom and 5 electrons, therefore we get 5 electrons. However, there are 3 oxygen atoms, and so we have 18 electrons from oxygen. In total, we will have 24 electrons in our Lewis structure. Nitrogen is our center atom. Nitrogen is bonded to oxygen, bonded to second oxygen, third oxygen, which is bonded to a hydrogen atom. Each of the bonds represents 2 electrons. Therefore, we've represented 2, 4, 6, 8 of our 24 electrons. Now, each of these, the oxygens and the nitrogen, need to fulfill the octet rule. They would like to have 8 total electrons. We can do that in part by creating a double bond between the nitrogen and one of the oxygen atoms, and providing lone electrons for oxygen. And if we then do that to create 8 electrons around all of the oxygen atoms and the nitrogen, we end up with the following Lewis structure. The question is this correct? First way to check is to count the number of total electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And indeed, that matches the 24 electrons we know that are present. The second thing we need to do is we need to calculate the formal charges on each of the atoms. Formal charge on nitrogen is equal to the valence electrons, which are 5, minus 1/2 of the bonded electrons. There's 2, 4, 6, 8. Minus the lone electrons. There are no lone electrons. This gives us 5 minus 4, which equals 1. That means there's a positive charge on the nitrogen atom. Let's check the oxygen atom. Oxygen has 6 valence electrons minus 1/2 of the bonded electrons. There's only 2 in a bond. Minus the lone electrons. 2, 4, 6. This equals 6 minus 1 minus 6, which equals -1. That means there's a formal charge of -1 on the oxygen atom. If we check the formal charge of this oxygen or that oxygen, we will find that they are equal to 0, or neutral. Overall charge on nitric acid is +1 and a -1, therefore making it neutral. And indeed, HNO3 is neutral.